Hello, everyone. Thanks for coming to this talk, and thank you, Data Hub, for having me. I'm a data scientist in Thomson Reuters Data Innovation Lab, and today I will talk about if we can detect money laundering and human trafficking using machine learning. What happened? oh, sorry. There is some technical hiccup, I think because of this new Max adapters. So it's okay. I guess this is, yeah.
All right. There we go.
Oh, okay. So Data Innovation Lab of Thomson Reuters works on 3 landscapes. So the first one is customer engagement. We are a customer-centered company who focuses on customer needs, and what we do, we unlock the potential of data using emerging technology to address the challenges professionals are facing. So we use our current capability to see if it solves our customer's problem. If it didn't, the next step would be exploration and research. We look at how we can address that challenge by using the current method, but beyond the products of Thomson Reuters, and we make a POC, proof of concept. We make a prototype quickly. We work with the customer, and if it was satisfactory, we make it as a product. So basically, in time horizon, the investment is fast, familiar strategies, which is current. And then the next focus is working on unfamiliar strategies, which will take more time, but it's more time. It has give more profit. And the third horizon is exploration and working on something that is unfamiliar, but will yield a higher profit. Data Innovation Lab is a network of 7 labs across the globe. We work with, so Boston Lab, as a part of Data Innovation Lab, we closely work with university as our research partner and a startup as our technology partner. So we make sure that Thomson Reuters is on top of everything. So Boston Lab is closely connected to MIT. Waterloo works with a startup, and University of Waterloo, Zurich is an incubator. So the people who work in the lab are data scientists, machine learning experts, natural language processing experts, full stack developer, designers, and so we have all expertise to work with a customer. We are coming from different backgrounds, so we understand our customer very well. A prototype that we built in Innovation Lab goes through collaborating with customer, brainstorming, coming with the idea, discovering, using visualization, and then rapid prototyping. Usually it takes 1 sprint, 8 weeks from scratch to making a product happens, a prototype of a product happens. Okay, so back to the talk. Today I'll talk about how we can detect money laundering using machine learning. Money laundering is basically the concealing process of the profit of illicit activities such as human trafficking, drug trafficking, terrorism. So a lot of effort is going into hiding the process from the source and the benefit from law enforcement. So money laundering is bad because it not only promotes corruption, it also destabilizes the economy of susceptible countries. And technology advances in e-commerce and financial diversification of the market is working against anti-money laundering activities. So it provides further opportunities for money laundering. Something like cryptocurrency is, I'll quote from Larry Fink, CEO of BlackRock. He mentioned that money laundering, based on the data they have, Bitcoin could be considered as an index for money laundering. According to United Nations Office of Drugs and Crime, the estimated amount of money laundered globally is about 5% of global GDP, or $2 billion, which is as much as United Kingdom GDP. And so there is harsh penalties on financial institutes if they fail in anti-money laundering activities. So based on Thomson Reuters news, penalties for financial crime and anti-money laundering failing in banks over the past 2 years have amounted to $8.9 billion. So the process of money laundering is going through 3 main steps. The first step is placement. It's where the profit from illicit activities should introduce into the financial institute. So deposit is one way, but of course there are other ways, something like inflating the income of a company or even front companies, buying assets, so this way, in a way that it doesn't raise any suspicion in law enforcement. The next step is layering. Layering is designed to make the system confused, so a lot of transaction, buying currency, sending money overseas. So the second step is layering, and integration is when all of the money from all other sources are combined, and now it's clean and could go into a mainstream economy. So I took 2 examples from our database to show how complicated a money laundering example will look like. So the first one is about human trafficking ring. So suspects assisted women to go to Australia on a protection visa, and in return the women owed them a debt which they rapidly repaid by working in brothel and transferred the money owed to the suspect in Thailand on a monthly basis. What led to suspicion of money laundering? So the following SMR and IFTIS were identified. International funds transfer to a country of interest, which was Thailand. A number of cash withdrawal amounted to a large amount, which was 50,000 Australian dollar. in a short period of time, and multiple transfer linked by a common address when conducting IFTIS, which was over $320,000 to the same beneficiary. So you see that a large amount in a small chunks. So the banks have some rules that if you transfer, I think here it's $10,000. So if you transfer money more than $10,000, a flag will be raised. And a couple of these flags might end up investigating your account and blocking your account. But the way they do it is they send money in a small chunks that end up being like a couple of hundred of thousands of dollars. Or in the next one, it's about drug trafficking. So a drug trafficking syndicate whereby payments were made to Romania believed to be funding narcotic imports. So if the process was transfers were sent to common beneficiaries overseas, transfers were in amounts below the reporting threshold, and over a 12 period, the sum of $840,000 were sent in a structured amount. So a structured is how you can send small amount of money that will add up to be huge. So it was a structure in amounts between $6,000 to $9,000. So when transferred the monies at separate remittance agents, they supplied multiple addresses, phone numbers, and date of birth. So this is kind of in order to mislead the financial institute, one person will provide different identification and makes it really hard to figure out that this is one person. So it's really hard to find a network of money laundering. The challenge is, first of all, it's not a one-man show. It's a network of people that work together to make it happen. So that's one problem. The other one is there is a behavior that, and detecting that behavior is very difficult since the system, the financial system, is rule-based. So these rules can be learned by the invader and bypass the rules. And so the patterns is also difficult to grab because they are very innovative, and rule-based systems are not designed to discover new patterns. And of course, the rule-based system generates a lot of false positives. So this is another burden for financial institute if they block someone, which happens a lot. False positive is a lot, and they have to spend a lot of resources to investigate and unblock an account. Okay, so what is machine learning? So machine learning basically is constructing an algorithm based on a data and make some conclusion and prediction using the data. So it's a data-driven approach. The model learns from the data and then predict or does some kind of prediction based on the data. Probably the first exposure of public to machine learning or artificial intelligence was Deep Blue back in 1996 when Deep Blue IBM machine won Garry Kasparov, the world chess champion, in 1 game out of the 6. And unfortunately, in the second round, Deep Blue won him in the whole tournament. So in general, machine learning is divided into 2 main categories and other smaller categories. So one of the main categories is supervised learning. Supervised learning is when we have training data. We know what we are looking for. So the algorithm has already seen, for example, a bunch of white token and black token, and now we ask the model to look into the mix of tokens and separate them into 2 categories. Supervised learning, usually in supervised learning, we need less training data. Whereas unsupervised learning is when we don't know what categories we have. We have a bunch of data and we want our algorithm to divide them into separate categories. So we want our algorithm come up with some features that are distinct among the categories. We have a bunch of mixed white and black tokens, and we want the model to figure out what is the difference and divide them into 2 categories. So a nice example of unsupervised is the right one. So a lot of pictures of different celebrities have been shown to the algorithm, and the algorithm was able to pick up George Clooney's face feature and categorize them on one, even though you see that there are different, his face is in different angles, or it's like a picture of far or close. On the left one, however, a lot of pictures of George Clooney, Brad Pitt, and other celebrities has shown with label to the algorithm, and as soon as the algorithm sees a picture, it's able to tag them. This is what's happening in Facebook. So when you have a picture of all of your friends, you see as soon as you want to tag them, Facebook has pretty much very good, can estimate which picture is which, especially if that person has a lot of picture of herself in her Facebook. The Facebook prediction of the name is very accurate. Now, if we want to think of money laundering and how we can solve money laundering using machine learning, we have to think of money laundering as a graph, as a network. It's not one shot. It's a network of transaction people going through countries that they are linked together. So it's a network analysis problem. A network, there are different methods to analyze a network, but one of the important features is the degree of a node. A node, or money laundering could be a financial institute, an account, or a person, is have a high degree if it's connected to many other nodes. The other characteristic is shortest path, which is very difficult problem to solve in nature. So shortest path is if A is connected to B with many different connection, what is the shortest path of A going to B? So exploration of that shortest path. And the other indication could be betweenness. So if a lot of transactions are going through this account, or if a lot of transactions are going through this country, this is the between centrality node. So this is what we made from our internal data in Thomson Reuters. So you see that there is between node that a lot of transaction. This is network of money launderer. So the nodes that are bigger, they have higher degree, and they are connected through this between node. And there are more complicated analysis. So clustering. Clustering a graph is can help us found the community of money launderer. So by clustering, we can find the nodes are intensely connected to each other and sparsely connected to other nodes. So this one, you see that these are communities that are very densely connected to each other, but the connection to the outside nodes are very sparse. Another method is PageRank. PageRank, probably you have heard of PageRank because it is what Google used to rank the results of the search. And it was named after Larry Page, the founder of Google. So it's the same for nodes. So it defines a strength of a node as number of its connection as well as quality of the connection. So for example, if a node, a person is mostly connected to people who do money laundering, there is a high chance that this person is doing money laundering too. So it's kind of evaluation of the quality of the node. And of course, time series, which is the most difficult part of discovering, part of this network discovery, looking at the network throughout the time. Money laundering and activation of these nodes doesn't happen. It's like being activated in short period of time, and the activation will fall. So if we are able to kind of monitor the network and look at the time series, it can help us figure out the pattern. So, oh, I skipped this one. I think, yeah. It's a bit slow, just bear with me. This is what we made to visualize, and it's done internally. Okay. So this shows a very famous network of money laundering. So I can't remember the name, but I think it made it to the news, and everybody knows that they had a front-end company. There was director, and they were sending money throughout throughout one between country. Okay, so machine learning. To apply machine learning to money laundering, we face a lot of challenges. The first one is high-quality data. So financial institutes usually don't collect all of transaction information about a client, so the data suffers from low completeness. All analytics methods need quality data in order to yield a good results. And this is the first thing we need. A 360-degree view of the customer. Currently, the financial institute don't share information with each other. So in order to find the network, we should be able to see how the network works through all of this financial institutes. So once, of course, there is privacy concern, but once the privacy concern was resolved and a cloud-based system, for example, established to share the data, then it's possible to have a 360-degree view of the customer, and then it would be possible to work proactively against money laundering network. So as I said, as far as I know, most of financial institutions have a rule-based system to grab, to raise some kind of flag against money laundering. But it's not machine learning. Rule-based system can discover new patterns. So the reason might be because there are not a lot of machine learning experts in financial system. They look at machine learning as a black box that they can trust. It's a complicated box, but definitely it's not a black box. So if we can, if there's a possibility that people in finance get trained and learn machine learning, or the other way around, this trust will be built. And unfortunately, even in a startup and established vendor, there is not a lot of solution for financial institute. So if it happens, then there will be a lot of solutions, and this will help anti-money laundering activity. So it comes to the last point. So if we can establish a system and we see the result, then the process could become more straightforward, understandable, and we can go ahead and establish that system. So in conclusion, the process is very complicated. And believe it or not, the people who do money laundering are smart. They invade the system. We don't share the data across institutions. So it doesn't help to discover those networks. If the data we have is only on the network that has been discovered, even we don't have access to a good quality data, meaning that we don't have a nice training data. We have one set of data, which is bunch of, even if we have networks all together, and one set of money launderer. So if we can somehow, government, I think, and banks and financial institutes work together, and while they are protecting the privacy of the customer, share the data across, it will give a good quality of the data to experts to work on it and work proactively against the money laundering network. So, and at the end, I will have a demonstration of our internal human trafficking data, which you can, so you can, it's a bit slow, I'm sorry. So when you can see the flow, for example, when you see like Azerbaijan, Turkey, and Uzbekistan, Turkey, and you see that it shows the flow of like how human traffickers flow people from Asia to Europe. And it's been color coded. So for example, Russia is one of the most popular one. Yeah. Okay, so thank you for, thank you for attending your call. So if you have any question, I will happy to answer.
Repeat it into the microphone.
Pardon? The question?
Yeah.
Oh,
So,
if, okay. Yes.
Yeah, so thank you for the presentation. I'm interested to get your sense of how easy it is to solve the access to data problem. Because obviously money laundering involves multiple institutions. I remember years ago I was sent by the World Bank to Estonia. Try to look at the money laundering from Russia, which is so close to them. And just the structural barriers by interfacing with the central bank of Estonia to get access across multiple institutions was extremely challenging. So how do you address today those issues? Do you get help from FinCEN or FinTrack to talk to central banks, etc.?
Actually, that's very difficult. And I'm not sure, for example, when we were looking at our internal data, there are a couple of countries that a lot of money is transferred through them. So even I think there is not incentive for some of the banks because it gives them a lot of, like it has a lot of profit. So this is one point. So we can work at this point. Internationally, it's too ambitious that we think that we can access to the data internationally. But even within Canada, for example, or North America and Europe, still there is a major privacy obstacle that we can't overcome and make this incentive that they share the data together in order for us to look at the patterns, and that might kind of help us to push that forward to other banks or countries. Yes.
Well, thank you for your presentation. I just have a question. In terms of like identifying the patterns, do you ever go through like third-party financial service providers like Interact to looking at, for of course, de-identified data through someone like them, because I guess it is a bridge in which a lot of people are transferring money anyway on an international scale. So isn't there a way to develop an understanding of the patterns and then getting the warrants necessary to then do a further investigation once you've picked up those patterns? Like, is it possible to work with another party if it's unidentified data or de-identified data?
So Thomson Reuters basically with a lot of institutions. So we have data. The problem with this pattern is once a pattern has been discovered, financial institute will implement that pattern. But this is what money launderer knows too. The good, like why I'm talking about machine learning, because it has the capability of finding anomaly. So if something is not following the majority of pattern, it can kind of categorize that as something to look into it. Yes. So any other question from, so online? Oh, okay, yes. Maybe because we have online.
So just kind of addressing what you just mentioned, that obviously once you develop a pattern, then they're going to, then the fraudsters or people doing money laundering will then change their patterns. How often do you have to retrain or re-update any of your machine learning models?
Oh, it's ever happened. So now it's a rule base. So they add rules. So if somebody is, so basically it's a rule-based system, and it's very complicated rule-based in financial institute. It's not machine learning. It's not intelligence machine. It says like if this person, if that much of money, if this is following this, and then, so very much it works like that currently.
Are you saying like if we put in a machine learning model, it wouldn't have to be updated as often as the rules to detect anomalies?
Yeah, because it's a data-driven model, right? And it can find the patterns that it's not following the majority of patterns, which is pretty much money laundering. They are not following the same pattern as individual. So, yes. Excuse me.
Thank you for the presentation. As you know, for federal regulated financial institution, there are so-called model validation regulation, right? At least in U.S. and also in Canada. So how you guys spend the effort on the so-called explainable AI for AML? explainable AI. It means it's no longer black box, but can be explained to the regulator clearly for your. Yeah.
So that's part of the suggestion, that it's good that some people, some financial expert train as machine learning expert or the other way around. That's, your question is right. It's really difficult to explain a machine learning algorithm to someone whose expertise is only finance. So if we can somehow train people who are expert in both domains, so hopefully those regulators will have a better understanding of this complicated algorithm and trust that. Any more questions? So online, we have, if there is online question, that's they are, pardon? Oh, okay.
So you mentioned one of the challenges getting high quality data. Then, how can you normally identify how high quality data? Like,
the data is very sparse. By low completeness, I mean like the data we have is very sparse. There are lots of unknown in the data we have. So financial institutes are not obliged to fill out all of transaction information about their customer. So that makes the data incomplete and sparse. Yes.
So just a quick follow-up to the question is that you mentioned earlier, financial institution, they don't really share data between themselves. How would you propose solving that problem?
Well, on one front, actually, Thomson Reuters is communicating with government, FinTrack, as well as, because this incentive should come from law enforcement. And the data should be anonymized because we have to protect privacy of the customer, right? So this is kind of an incentive coming from government, and then we are working with government, banks, financial institute, and the incentive is there. So, but government should make sure that they wouldn't expose individual, and that's the part that takes some time for it happens.
Sometimes to track down the individual because some individuals isolate them. So we try to balance between privacy and trying to build a more effective model.
Yeah, that's really hard. So, exactly. So data anonymization happens in all fields. For example, in medicine, it happens, but it should happen in financial world too, right? So it hasn't happened yet, but there should be some protocol that protect everybody, law enforcement, privacy. So, and this is at least, once they came to this conclusion, then they have to build this system that protect everybody. Yes. Okay, so thank you, everyone, and thank you, Community Data Hub, for having me.
Thank you.